All right, let's go through this acceleration Pogil and hit the high points and make sure we go over all the answers. So the first thing that I wanted to do was go over question 1. So does a sprinter who runs a race on a straight track starting from rest and reaching a top speed of 10 meters a second accelerate? Yes, because that sprinter is speeding up. On the second one, a car is traveling along a straight section of racetrack at a constant 90 meters per second. There is no acceleration because not only is there no change of speed, but there's also no change in direction. A cyclist traveling around a curve at a constant 13 meters per second. Yes, there's acceleration because the direction is changing even though the speed is not changing. And finally, D, a train is moving at 20 kilometers per hour, coming to a stop at a station along a straight section of track. Yes, there is acceleration because the speed is slowing down to a stop, even though direction isn't changing. So let's take a look at number 2. For each of the following descriptions, we want to talk about whether they're a time, a distance, a velocity, or an acceleration. I use the word speed instead of velocity. Cat runs at 13 meters per second. That's a speed because we're talking about how fast the cat's going. 100 miles took 2 hours, so we have a distance in a time. That's also a speed or velocity. A frog completed a hop in 0.28 seconds. That's time, so how long it took to happen. Distance, ball is kicked 65 meters. That's how far it went. A drag racer starts from rest and reaches a bigger speed in 4 seconds. So it's the rate that the speed is changing. That's acceleration. An airplane is moving west at 200 kilometers per hour. That's a speed. Acceleration is a cyclist turning right on a trial while maintaining a constant speed of 10 meters per second. So the speed is constant, but we're changing direction. So we're changing our speed or changing our velocity. So that's acceleration. A ball fell 250 centimeters. That's how far it fell. That's a distance. So what are 2 ways that an object can accelerate? Either the speed can change, either it can speed up or slow down, or the direction can change, even if the speed stays constant. I'll get rid of that. So what is the difference between velocity and acceleration? Velocity is how fast you go, how fast you change your position. Acceleration is how fast you change your velocity. So as an example, I drive a little Honda. My car can absolutely go 0 to 60 miles an hour. It can totally do that. And that's the same as a Porsche. But the Porsche can do that change of speed a lot faster than my little Honda can. It takes it a little while to get up to speed. So both cars reach the same velocity, but the Porsche has bigger acceleration. It can do that change in speed faster. So calculating acceleration, we've got the change in speed divided by the time and order of operations. Parentheses happen first, then exponents, then multiplication, then division, then addition, then subtraction. So PEMDAS, if you remember that. You have to plug this into your calculator correctly, otherwise you won't get the right answer. So when you're doing 12 minus 5 divided by 2, put the stuff in parentheses on the top, so you can type this in as parentheses 12 minus 5, end parentheses, divided by 2. So it will do the 12 minus 5 first before it does the divided by 2. The other way you can make sure that that happens is if you don't use parentheses, type in everything on top, get an answer by hitting enter, and then divide that answer by 2, and that also works. And just a quick note here, there's often 2 minus signs that are on a calculator. One of them is actually minus, and the other one is trying to make something negative. Usually the negative sign looks like a plus or minus thing. Make sure you're using the minus sign if you need to minus. So let's take a look at some of these problems. So on 5A, a sprinter starts from rest. There's that hidden given word in there. Reaches a top speed of 10 meters per second in 5 seconds. So our V initial is 0. Doesn't say that he starts from an initial speed of 0, but he does start from rest. Rest is code for that, so VI is 0. Then he reaches a top speed of 10 meters per second. I know that this is the speed because it's meters per second, and that's the ending up speed. So that's going to be V final. And then that happens in 5 seconds. So that's our time. So seconds is a time unit, meters per second is a speed unit. We're asked to find the acceleration for all of these. So our equation, V final minus V initial over T. Our substitution, V final is 10, V initial is 0, and then our T is 5. When we plug that in, we're going to get 2 meters per second squared. The next one, we're going to speed up to 30 meters per second from 10 meters per second, and that happens in 30 seconds. Time is my easiest one to figure out because that's the seconds, so I know that that's T. These are both speeds because they both have meters per second in them. So we need to decide which one is the starting speed and which one is the ending speed. So it goes from 10 meters per second to 30 meters per second. So the 10 meters a second is my starting speed, that's my VI, and then 30 meters a second is my ending speed, that's VF. The givens is often the hardest part of solving a problem. Once you have the givens, then you can plug that into your equation and get your answer. Here we have 30 minus 10 divided by 30. That's going to give us 20 divided by 30, which is 0.66666 repeating. We don't want to leave all of those digits, so I rounded to one of those. That would be 0.7 meters per second squared. Notice that I didn't round it to 1. I'm going to keep that first digit and decide whether it stays a 6 or whether it goes to a 7, and that's what I'll do to round that one. Next one says a truck is traveling 30 meters a second, slams on the brakes, and stops in 4 seconds. So again, my time is the easier one, 4 seconds. I know it's a time because it's in seconds. So now we have to figure out what our beginning and ending speed are. So it was traveling 30 meters per second, and then it stops. So stopping means that you're going to end up with a speed of 0. So we start with 30, that's our VI, and we end with 0. So our V initial is 30 meters per second, our V final is 0, and our time was 4 again. We plug that in, and that's going to give us 0 minus 30, because our final speed was 0, our initial speed was 30. I can't switch the order of those two, and then that's divided by 4. When I do 0 minus 30, I'm going to get a negative 30. So it will be a negative number. The acceleration will be a negative 7.5 meters per second squared. That means that it's slowing down. So that negative acceleration means that it's slowing down. The other two that were positive means that we're speeding up, that we're getting faster. Now we can rearrange this equation to solve for different things. We can have A is equal to V final minus V initial over T. We can solve for V final, that's AT plus V initial. We can solve for V initial, is V final minus AT, or we can solve for time, which is V final minus V initial over A. So the car starts from rest and accelerates at 3 meters per second squared. Notice that that looks different than a speed, that instead of having 3 meters per second, there's a little squared on there that tells us that it's not a speed, that it's an acceleration. It reaches a final velocity after 15 seconds. So we start from rest, so that's our V initial. Our acceleration is 3 meters per second squared. Our time is 15 seconds. We want to know what is the V final. I like in the givens writing the thing I don't know because that helps me identify which equation I need. I'm going to pick the one that solves for V final. So this one solves for A, this one solves for V initial, this one solves for T, this one solves for V final. So I'm going to pick this equation because it's already solved for the thing that I want to know. So then I can plug in my values. My A is 3, my T is 15, and then I'm going to add 0 to that, so it's 45 meters per second. Next up, a kicked ball is traveling at an initial velocity of 50 meters per second and slows to a stop with an acceleration of negative 20 meters per second squared. So we're traveling at a start of 50 meters per second. That's the speed, and that's our initial speed. It's the one we start with. It's going to slow to a stop. That tells me my V final is 0. And my acceleration is a negative 20 meters per second squared. And again, I know it's an acceleration, one, because it tells me in the problem it's acceleration, but two, because it has a squared on the second. So it's not normal speed, it's got an extra time unit in there. We want to know the time it took for the ball to come to a stop. So t is what I'm looking for. So in my equation list, I'm going to pick the one that already solves for t. So t is equal to v final minus v initial over a. Then I plug in. V final was 0. V initial was 50. And I'm dividing by negative 20 because that was my acceleration. So I'm going to have a negative 50 divided by negative 20. When you divide negative by negative, you get a positive answer. Time should always be positive. It'd be really cool if we could have negative time. If we could go backwards, that would be so awesome. But we can't do that. So time should always be positive. If you ever come up with a negative time, it means you've done something wrong with a sign. C. A rocket is soaring through the atmosphere towards space when it fires its second stage engines and accelerates 0.1 kilometers per second squared for 30 seconds, reaching a final velocity of 11 kilometers per second. All right, lots of stuff here. We've got 0.1 kilometers per second squared, that's an acceleration. Got 30 seconds, that's time, because seconds is a time unit, so we've got 30 seconds. We have a final velocity of 11 kilometers per second, that's our VF, and we're looking for VI. So I'm going to choose the version of the equation that already solves for VI. VI is equal to VF minus AT. That's what I'm going to choose. So I'm going to have 11 minus 0.1 times 30. And I'm going to type that into my calculator. That's going to give me 8 meters per second. And D. A roller coaster's velocity at the top of a hill is 10 meters per second. 2 seconds later, it reaches the bottom of the hill with a velocity of 26 meters per second. What is the acceleration of the roller coaster? So we're looking for acceleration. So we've got the top of the hill, it starts at 10 meters per second. Then it gets to the bottom of the hill at 26 meters per second. So both of those are speeds. So we have 10 meters a second and 26 meters a second. It starts at 10 meters a second and then becomes 26. So our VI is 10 meters per second. Our VF is 26 meters per second. And if you don't read carefully, it's easy to miss the other given in this problem. 2 seconds later. So they didn't put it as a 2 with the seconds next to it. They actually kind of hid it in words in the problem. Watch for that. If it seems like you don't have enough givens, that's probably what's going on. So our t is 2 seconds. So we would need to find acceleration. We're going to go back to that same equation we were using before. A is equal to v final minus v initial over t. So our v final was 26, v initial was 10, our time is 2, and that'll give us 8 meters per second squared. Again, that being our acceleration units. Different than speed units because of that squared on there. So going back to graphs. The velocity is the slope of a dt graph. The slope of the vt graph is acceleration. And is this graph an example of constant velocity? No, it's not, because if we read velocity off of this graph, we start at 0 and we end at like 75 meters per second. That's not constant. So 0 is not the same thing as 75. We're getting a lot faster. We're starting at 0, we're getting to 75. So our velocity is not constant, it's changing, it's speeding up. But is it constant acceleration? Yes. The slope of this line is acceleration, and it's not changing. I have the same slope here as I have here, which means that my acceleration rate is staying exactly the same all the time. So my rate of speeding up is the same. So if I were pressing on the gas pedal, I'm pressing on the gas pedal evenly hard the entire time that I'm changing from 0 to 75 meters per second. I'm not pressing a little bit, then a little bit harder, then a little bit less. I'm applying that same amount of pressure the entire time so that my acceleration rate stays the same as a constant rate.